So now we'll discuss the internal energy, okay, which is denoted by U, capital U. So we know for a gaseous system, the gas molecules can move in any direction in straight line, okay. So the gas molecules can move in any direction in straight line. For example, suppose in this case, the gas molecule is a diatomic gas molecule. But whether it is a monoatomic, diatomic or triatomic or polyatomic gas molecules, they all can move in a straight line and in any direction. So it has the translational motion. So it has some translational kinetic energy associated with the translational mode of motion. Next, if other than the monoatomic gas molecules, other gas molecules such as the diatomic, triatomic or polyatomic gas molecules then can have the rotational mode of motion. For example, in this case, as you can see, we have a diatomic gas molecule and it can move. We have already discussed in the degrees of freedom that they can have 2 degrees of rotational degrees of freedom or 2 degrees of freedom associated with rotational motion. So the gas molecules can either move in this way or in this way for this diatomic gas molecule. So the diatomic gas molecules and the other polyatomic gas molecules, they have this rotational kinetic energy. But for the monatomic gas molecule, as they cannot have the rotational kinetic energy, they will have only the translational kinetic energy. Now, the polyatomic gas molecules which have some chemical bond between the atoms of the molecules, they can also have the vibrational mode of motion. For example, in this case, you see we have this diatomic gas molecule with these 2 atoms. Now you can consider this the bond between them to be like a spring. Okay, so so they can move back and forth like this. Okay, or they can oscillate. Okay, or you can say vibrate. Okay, so the polyatomic gas molecules where there are some bonds between the atoms of the molecule, they can also do the vibrational motion or the oscillation. Okay, so they will also have another type of kinetic energy which is vibrational kinetic energy. Now, for the ideal gas, we say that there is no intermolecular force acting between the gas molecules. Okay, so as there is no intermolecular force, whether attractive or repulsive, they will have no potential energy between the gas molecules. But for the real gas, we say that we have seen that there is indeed intermolecular forces suppose the attractive intermolecular forces acting between the gas molecules. So the real gas molecules will have also potential energy in addition to this this kind of kinetic energy. Whereas if you consider the gas to be ideal, then we'll say that the ideal gas molecules will only have this kinetic energy, 3 modes of kinetic energy, but no potential energy. But for the real gas molecules, they will have potential energy due to the intermolecular forces in addition to this 3 modes of kinetic energy. Okay, so if we add all this kinetic energy and the potential energy for the real gas molecules, okay, then what we will get? We will get the internal energy. So how can we define this internal energy? So we can say that the form of energy which is inherent in every system. Inherent means, so we are saying that the internal energy is inherent in every system, means it is the characteristic energy of the system. For example, suppose as long as there will be, we know that normally all the gas molecules of a gaseous systems are always in motion. Okay, so they always have this kind of kinetic energy, whether translational or rotational or vibrational. Okay, and there is also intermolecular forces acting between the gas molecules, so they should also have the potential energy, of course, for all the real gases. Okay, so it is this energy. If we consider all this energy, then it will be the characteristic energy of every system. So that's why it is called the inherent energy. So the internal energy is the form of energy which is inherent for every system. and it arises, why does it arise? It arises due to the molecular state of motion of the matter. Just like we said that all this motion, this translational motion or the rotational motion or vibrational motion or the intermolecular forces, okay, and so all these are arising due to this molecular motion, okay, or the motion in the molecular state or the atomic state, okay. So this internal energy is arising due to molecular state of motion of the matter. So the form of energy which is inherent in every system and which arises due to the molecular state of motion of matter is called the internal energy of the system, okay. So how do you measure internal energy? So it is the sum of the total kinetic energy. So the translational, vibrational and the rotational kinetic energy comes under this total kinetic energy, okay. So it is the sum of the total kinetic energy and the potential energy. So under this potential energy, consider the potential energy which is arising due to the intermolecular forces as well as the which is arising due to vibrational mode of motion or the oscillation or the vibration of the gas molecules. Because we know, so suppose if we have a mass and spring system, and then we know due to the motion of the spring along with the mass, it has the kinetic energy as well as also potential energy, okay, for a mass and spring system which is in motion. That's why the potential energy will arise due to the intermolecular forces as well as the vibrational mode of motion. Now it also includes the energy of the chemical bonds, okay. Like for example, see, you know, there is chemical bonds. It can be a single bond or double bond or triple bond, okay. So the internal energy also includes the energy of the chemical bonds between the atoms of the molecules as well as the electric energy between the atoms of the molecules. For example, hydrogen bond, etc. Okay. Now the internal energy is which is denoted by U is a state function. That is, it depends only on the state of the function at that instant of time. It does not depend on the path which is taken to reach that or establish that particular state, okay. Then internal energy is also an extensive property. Now you know, extensive property are those properties which depend only on the mass or the amount of mass or the number of particles in the system. Now how do we measure internal energy? We measure the internal energy by taking the sum of the kinetic energy and the potential energy for all the gas molecules which are present in a system. So if the number of gas molecules in the system is more, then the total energy of the gas molecules will also be more, okay. So thus the internal energy of the system will be more. That's why the internal energy is an extensive property which depends on the number of molecules or the mass of the system. Now as the internal energy is basically a form of energy, SI unit is joule. Now it is separated in scale from the microscopic ordered energy associated with the moving objects. It means that generally suppose we have a car moving, okay. So the energy, so if we have a car moving, then we can measure its kinetic energy, okay. And suppose you throw a ball upwards, then while the ball is moving upwards, and then it will have its kinetic energy as well as it will have potential energy, okay, because it is moving upwards against the force of gravity, okay. So but those are not considered the internal energy, because you can sense or you can measure those energy, the kinetic energy and the the potential energy, suppose of a moving car or moving ball, in the microscopic scale. That is, you can sense the measure this energy by using your senses, okay. And those are occurring in the microscopic scale, okay. But this internal energy which is arising due to the random motion of gas molecules, not gas molecules, random motion of any molecules of matter, okay, molecules of any matter, whether gas, liquid or solid. So this energy is arising due to the molecular motion of the molecular motion of these matters. Okay, so it refers to the invisible microscopic energy, because now you cannot see that the molecular motion. Okay, whether the gas molecules are doing translational motion or rotational motion or vibrational motion, you cannot see that. You cannot observe them or sense them. Okay, they are not perceivable by your senses. So this energy and the internal energies are arising due to those molecular motion, random motion of the molecular random motion. Okay, so this internal energy is basically the invisible microscopic energy at the atomic and molecular scale, which is completely different from the macroscopic movement of the object. Okay, or the energy associated with the moving objects on the macroscopic scale. So for example, suppose we have a glass of water sitting on a table. Okay, so apparently as the glass is not moving, it will not have kinetic energy. Okay, and as the suppose we take the level of the table to be the zero level for the potential energy, so apparently it will not have potential energy. Okay, so there is no apparent energy of the glass of water on a macroscopic scale. Okay, so if a glass of water is sitting on a table, okay, and it is not moving, the table is not moving, the glass of water is not moving, or you are not lifting the glass of water upwards, then apparently it will have no kinetic energy or potential energy. But on the microscopic scale, the water molecules are always moving. Okay, so you see these water molecules are always in motion, so they have this microscopic energy, which is a part of the internal energy, and there is also the intermolecular force acting between the gas molecules. Suppose this is the intermolecular attractive force acting between the water molecules. Okay, so there is the intermolecular attractive forces which is giving rise to this potential energy, which is also part of this internal energy. So apparently on the macroscopic level, some matter, any object or any matter may not have any energy, but on the microscopic level, as the molecules of the matter are always in motion, they will have kinetic energy, and they also have the intermolecular force acting between them, which is somewhat less for the gas molecules, but it is quite evident for the solid and liquid molecules. Okay, molecules of solid and liquid matter, so they will also have the potential energy, which is giving rise to this internal energy.